Hello everyone. Today's demo is related to a tool called Matheel. It's a source code similarity tool. It has two main tasks. The first task is the code pair similarity. The second task is related to code collection pair similarity. So here it is hosted on Hugging Face spaces and it's running on CPU, so it might be a little bit slow. So for the first task, we have the input to be a pair of codes, and the output is the similarity score between these two codes. So for example, we have this code, which is the original code. We can paste it in code 1. And we have the second code, which is the plagiarized version. So here we have exactly the same code as code 1. With slight differences. So here they have one single import and shorter names, MAs and M, and different spacing. So it's like being copy pasted and then changed a little bit. So this is a plagiarized version. So we should have a higher similarity between these two source codes. So while it runs, here we have the parameters that we can adjust. So this is a hybrid tool combining semantic similarity with syntactic similarity. So here we can adjust the weight of the semantic similarity, and here we have to edit distance measures. We can adjust their similarity, and here in the research paper we have 6 models and we can select either one of them. We got the result to be 0.86, which is 86% nearly, which is considered high. So if we take a non-plagiarized version, so this is using the same, this is answering the same problem but differently, using a different way. And here we can paste the code, and let's see, it should be lower than this. So here we have the similarity to be 0.78. So which is lower than the first one. Here we can, another task we can do is to have the compressed file full of codes, and we can get the pairs with the highest similarity here. So this here we have a list of the first code and the second code and their similarity sorted descending. We can upload a sample here, and also while let's run it. While it executes, here we have the same 3 measures, similarity measures, and here we have the model. 2 more extra parameters here is the threshold and the number of return pairs. So threshold is usually used in source code similarity tools, which we can get the similarity scores higher than a certain threshold. For example, if we get 0.79 here, we will get the first 3 ones. And the number of return pairs. In case of having lots of files and we would like to have, let's say, the first 10 with highest similarity, we can use this parameter. So here we got the results. So the results here we have the plagiarized versions have higher similarity, the non-plagiarized ones have lower similarity, while the non-even related codes are even lower similarity. For example, this is hello world with a different problem. So this is one way to use the tool, which is being hosted on Hugging Face spaces. Another way to use the tool is we can use it locally. For example, this is a Jupyter notebook, which can be used locally. So it's the same exact interface. So here we can quickly copy this code into the code 2 and copy the first code into code 1. and we can estimate the similarity score between them. Okay, so this is faster because it's running on GPU on my laptop. And if we let's test the second task, which is uploading a file. I have the same sample file here, and we can run it on the tool, and we can get the pairs with the exact similarity scores. Okay, so this tool can be used either hosted on a server or it can be used locally. Another way to use the tool is this is built on Gradio, which has lots of features. So one of the features is they have an API call using Python or JS. So we will use Python here. So here I'm defining the same code 1, 2, and 4, which is the first one, the original one, plagiarized version and non-plagiarized version. So, and here we can run the tool with the codes 1 and plagiarized, and here we can set whatever parameter that we would like to set. So here it's calling the Hugging Face spaces, and we are getting the results, and this is for the plagiarized pairs, and this is for the non-plagiarized pairs. We will get, this is 86 and this is 78, and here we have the compressed file. It's on the same folder, and we can use the same, we can adjust the same parameters. And here we got the results in a text format, which is exactly the same, 0.86 here and 0.78 here. So this concludes our demo for today. Thank you for listening. I hope that you enjoyed this demo. Thank you all. See you. Bye-bye.